So what the questions we wanted to ask is how much do these pest fish actually contribute to the overall nutrient recycling at an ecosystem scale, and is removing these pest fish gonna reach our target TLIs, or is it actually going to restore the lake to a water quality that we'd like? So the outcomes of my study were we want a more detailed and comprehensive nutrient budget and a quantitative assessment of the fish removal or the biomanipulation. You probably all know the effects of koi carp are quite wide-ranging. They were first introduced into New Zealand in the 1960s, spreading through the Whangamarino swamp and then out into the Waikato river system. They're regarded as one of the most ecologically destructive invasive species, and especially in shallow lake ecosystems, degraded lake ecosystems, they can have a huge effect. This is due to their feeding activity. Bruno showed a really neat video, which I'm going to have to get a copy of, showing the feeding activity, the benthic feeding activity, resuspending sediment, and it can also resuspend nutrients and chlorophyll that settle onto the bottom. There's a wide range of critical biomass for ecological effects, but some studies do say 200 kgs, 150 like Nick said, or even 50 can have an effect. This is due to their feeding activity, but they can also excrete large quantities of nutrients. Morgan and Hicks did a study where they estimated that nutrient excretion, which we've reused the results from in this study. And they can contribute to the collapse of macrophyte populations. Their feeding activity resuspends sediment, which decreases light penetration, and they can also directly uproot macrophytes. So Lake Ohinewai, there's a couple of pictures in the slide showing some algal scum, and one of the perpetrators just lurking here. Potentially one of the perpetrators we'll see in the results of the study. But yeah, within the catchment we've got 360 hectares, 84% dry stock, 13% dairy, and carp are now reduced from about 240 kg per hectare to about 20 kg per hectare at the moment. A little bit of historical water quality data. There was a really good study done in 1981 where they looked at the ecology, chlorophyll and water quality in the lake. It showed that the lake was already eutrophic to supertrophic, and this is before the carp invasion. And at this time there were macrophytes present, although the study did show that they were showing signs of decline. So we think that carp got into the lake between 1980, probably the late 1980s or 1990s. So carp may well have contributed to the macrophyte, the current macrophyte absence that we see today. And the lake probably flipped to an alternative stable state, which is phytoplankton dominated. So here's the lake and the catchment. It's about maximum depth 4.5 metres. We're still unsure of some of these catchment boundaries. The elevation is really, there's not much variation, so and some of these drains can flow in various directions depending on the water table and the lake level. But yeah, we'll adjust that accordingly if we find some new information. So these are sort of preliminary results, and we're still working on model calibrations and things like that. So yeah, the current situation, we've reduced the carp biomass. I'll show a couple of the initial scenarios that we've run. The current situation, of course, a scenario to predict what the trophic state of the lake may have been when the catchment was comprised of native forest and there were no fish, of course, no carp. There hopefully would have been native fish at that time. And a restoration scenario where we have the current carp biomass, but we reduce the N and P external loading of the lake by 50%. And that there's a lot of studies out there looking at integrated catchment management and showing that you can actually reduce the external loads from the catchment by up to 50 or 60% for N and P. In reality, that's shown to be quite difficult for some catchments, even when you make changes to land use. But yeah, this is just the first of the restoration scenarios that we're going to be running. So N and P loss, we want to model that catchment using a catchment model called INCA and model the flow and nitrogen, phosphorus and suspended sediment flowing into the lake on a daily basis, and use INCA as a process-based model. Just quickly, N, we can lose N, the major source is leaching. For P, the major source is overland flow, although you can get leaching, especially in when soils are peat-based, which they are in this catchment, some of them, because peat has a low anion storage capacity for P immobilisation. So just quickly, some of the results from the process-based catchment model INCA. Discharge is highly variable, and nitrate and ammonium. So it just predicts a daily time series of these. And for phosphorus, the same thing. We see a lot of the phosphorus gets into the lake through storm events and high rainfall events. So once we run the catchment model, then to determine the contributions of pest fish, we're using another process-based lake model called Dyers and Kadam. Kadam, David Hamilton was instrumental in creating Kadam. The model is now owned by CWR. Through Dyers and Kadam, we model carp by modelling their effects, not specifically modelling their population. So we modelled carp excretion through a nice paper that Morgan and Hicks published, and based on hydrodynamically simulated water temperature. We modelled carp resuspension rates based on overseas studies. And this is just a schematic of the processes involved in Dyers and Kadam and some of the input data. So you need wind, you need your inflows, and all your meteorological data, solar radiation, etc. So just some of the forcing data that's gone into the model. Just like I said, mentioned before. And we get to the current situation that we're modelling today, where in 2011, carp removal proceeded for the next year, basically. The blue dots are the measured data. The black line is the simulated data from the model. We can see, yes, the model does estimate that total suspended solids have been quite dramatically reduced through the removal of carp, and the model simulates that. The field data simulates that as well. The field data not simulates, but shows that as well. You can see, although throughout this period before the fish removal, we've got large algal blooms. We haven't seen really large algal blooms since then, which is great. So there's some encouraging signs. Total nitrogen, total phosphorus hasn't changed hugely. You can see the model is doing quite a reasonable job of simulating the TLI. The model is not doing such a great job of simulating NH4, NO3. That's quite normal in a shallow lake system like this. So if we compare the current situation to one of our scenarios where we would look at what the lake would have been like with the catchment completely in forest, the blue line is what the lake would have been like covered in forest, and the black line is what the current situation, including the pest removal. And you can quite clearly see that the TLI is much lower than it is now. This is going to be a rough estimation, but at TLI 5, that's a lot more conducive to having macrophytes in the lake. Currently the TLI is over 6. Secchi depth is much higher under native condition. Maximum depth of macrophyte colonisation is a lot higher. So you can see that the conditions were probably historically quite different in Lake Ohinewai. So if we just quickly go through the results of the different scenarios and trying to quantify the contribution of pest fish to the total nutrient loading of the lake. So we've got the total N load in tonnes, total P load in tonnes. You can see that at a density of 240 kgs per hectare, which was the case at the start of 2011, the TLI is 6.28, and we see that the carp actually contribute a significant load to the total phosphorus and total nitrogen. So at 240 kgs per hectare, the carp are contributing 30% of the total phosphorus loading, 11% of the total nitrogen loading. If we move to the current situation we see today, this has been reduced dramatically to only 1% and 3.88%. So you can see that the contribution of carp has been dramatically reduced. Has the TLI changed hugely? Well, no, it hasn't changed dramatically. Currently, in the current condition, the TLI would be 6.14. Under Carp 240 would be 6.28. But then you've got to consider that, yes, there has been significant increases in water clarity. Is it going to meet our expectation to restore the lake? Probably not. We're going to need to use integrated catchment management to restore the lake back to a condition where the water quality would be acceptable, or a condition where we could re-establish macrophytes. So next we need to set probably a TLI target for restoration. The removal of the carp was essential to restore the lake, but we still need to do more to restore it. So we're going to come up with a bunch of restoration scenarios, which include integrated catchment management, changing of land use, etc. So the take-home message, carp contribution is significant, but integrated catchment management is going to be needed to restore the lake significantly. Once we reduce the external loads, overseas work has shown that the internal loading, so the phosphorus released from nutrients stored in the sediment, can last up to 20 years after you reduce the external load. So it could take a long time to restore this lake. And we're going to need to get back to an alternate stable state where the lake is macrophyte dominated and the clarity is a lot clearer, but it's going to be quite a difficult task to get to that state. Results from this lake are non-transferable, so for each lake the nutrient budget is completely different. There's different contributions from internal and external loading. So for each lake the contribution from carp is going to be different. So we're going to now model some more lakes, and just to note that these are preliminary results. Your results can change with model calibration. So just a final slide. We need more collaboration in modelling generally, and we need to really work on improving current models that have been created and cooperation rather than trying to recreate really complex lake models. So just a few acknowledgements.